Hi everyone. Welcome to our first video lesson. I'm a little rusty. It's been a while since I made a video lesson, so kind of bear with me on this first one. And I haven't used Screencastify before. I use a different platform in not the summer, I wish, the spring. So again, just kind of bear with me through the kinks on this first video. So you should have your notes that kind of look like this, and we're gonna fill them out together. And that will be it, okay? So why don't you grab out your notes. Now I'm going to make this bigger here. Oh, there I am. Perfect. Okay, let's just see how this goes, okay? So our first lesson is on points, lines, and planes. These are kind of like the building blocks of geometry. We're going to be able to identify them, see what they look like in a picture, be able to tell the difference between certain things and like their intersections. It's kind of just a whole lot of vocab today that we'll use throughout the whole rest of the year. So kind of boring, to be honest. Like I said, it's a lot of vocab. So just kind of hang in there. So normally I'd have this presented to you on my smartboard. So it's a little different than your notes, but you'll catch up in a moment here. So what are points, lines, and planes? Well, unlike the real-world objects they model, points, lines, and planes do not have any actual size, which I know is kind of hard to think about. In geometry, points, lines, and planes are considered undefined terms because they are only explained using examples and descriptions. So no one really knows, because there is no size for a point and a line and a plane. They just kind of go on forever. But we can use real life objects to model these to help our brains kind of grasp what they are. That's kind of what this is saying here. Don't be confused. If you're confused, we'll get you there. Just hang tight. So this is where you come in. So this is the top part of your notes. So we're first going to start with a point. You are going to label kind of like the bolded words. That's what's missing. So a point is just a location. It's just marking a spot. It has no shape or size. And how we label a point is we always use a capital letter. So in our example here, this would be considered point A, and you literally write out point A, and just make sure it's a capital letter. So remember, a point is just a location and has no shape or size because it's an undefined term. Okay, there we go. Our next undefined term is a line. Now, a line is made up of points. It's actually made up of an infinite amount of points. There's like a million little points all in here. You can make a line from any 2 points, from anywhere. Just find 2 random points in the world and space and connect them and you'd have a line. You just need 2. This line has no thickness or width, again, because it's an undefined term. And we name a line by picking any 2 points or a lower script letter like this. So let's kind of see what that would look like. So I could call this line XY. You could say XY with a little line on top. That's a way to name it. Or you could call it line and then use that little cursive script letter there, N. Those are some different ways to name it. And actually, you can flip the order of your X and your Y. So I could also have YX if you wanted, or line YX like that. The order of these 2 letters, it doesn't matter. So that's kind of nice. Just remember, a line, you need 2 points. A point is 1, a line is 2 points. You kind of want to underline this next part. We're going to use these words a lot this year. Collinear points are points that are on the same line. So they're collinear because they're on the same line. So x and y are collinear because they are on line N. So duh, non-collinear points do not lie on the same line. So if I had some random point z over here, you could say z is non-collinear with x and y because it's not on this line here. And you must have at least 3 points to be non-collinear. And it's like, well, why does that make sense? Well, if I just have two random points, let's call this A and B, technically there is a line that goes through there. But if I have C someplace off in the distance, like right there, is there any way for me to draw a line between all of these points at once? Okay, sorry, that's my dog. She's crying. She wants me to play, but we'll do it after notes. So non-collinear, you must have 3 points, like this situation here. Okay, how do we feel? We'll get there. A lot of new vocab, a lot of weird vocab, but it'll become solid by the end of this video. Okay, so now we're on to our last undefined term, and that's a plane. So remember, a point was 1 point, a line was 2 points. Now a plane is made up of at least 3 points, okay? So a plane is a flat surface made up of a bunch of points. So there's a bunch of different points on here. But we need at least 3 to make one up. A plane extends indefinitely in all directions. So think of it kind of like the top of like your desk, that's a plane. Or like the sides of a box, those are planes. They're just a flat surface. Or your bedroom walls, or the ceiling, or the floor. Those are all planes. You name a plane by using any 3 non-collinear points on the plane. So I think you should do one of these jobs. Circle that. So again, remember, non-collinear means they are not on the same line. So if I look here, is there a way for me to draw a line between K, J, and L? Nope. So these would be non-collinear. So I could say plane KJL. And you can do any combination of those letters. So I could say plane JKL or LJK. It doesn't matter. And then the other way to name it is using this cursive letter in the corner. Do you guys see how there's not a dot by it? So this isn't a point. This is naming the plane. So this would be plane P. How do you feel? I wish I could see you so I could know. Then we have two vocab words here. Coplanar points are points that lie on the same plane. Just like collinear are on the same line, coplanar points are on the same plane. Non-coplanar points, you guessed it, are points that do not lie on the same plane. And you need at least 4 of these. Why? Because at least 3 points make up a plane. Okay? The next part in your notes is when these 3 undefined terms intersect, what do they make? What happens? So if I have 2 lines that intersect, their intersection is a what? So P is identifying this guy right here, which we know is a point. So 2 lines intersect at a point. Here we have 2 planes. Do you guys see the 2 different ones? We have a horizontal plane M, and we have a vertical plane L here. And again, since these kind of go on indefinitely like this and like this, they actually form a line. So all of these points, they share. And it would keep going, and it would keep going. And we know that all these points are on this line. Okay, so 2 planes intersect at a line. Okay, folks, on the home stretch. So we have all this new information, and now we got to do something with it. We got to apply it to something, right? Otherwise, what's the point of doing it? So it says, use the diagram at the right, which is actually on top of my paper. Sorry about that. To name the following. So it says, name 4 collinear points. Well, we know collinear means on the same line. So I have to find 4 points on this picture that are on the same line. Well, the only 4 that work are H, N, K, and I. So we're going to say points H, N, K, I. B, it says a line that contains point M. So here's M, and it's on this line here. So we have a few ways that we can actually name that. Let's just pick 2. The easiest one would be just calling it line P, right? Because that little letter tells me it's line P. Or remember, if you pick 2 points on that line, you can name it. So if I pick like O-N, I could say O-N and draw the little line on top. And again, there are more ways. This is just one, right? Okay, C, a line that contains points H and K. So here's H, here's K. What line is that on? Well, it's on line R. So we could say line R, or let's pick 2 points on there. Should be like H and N. D, another name for line Q. Here's line Q, and we just said 2 points, name a line. So pick 2 points on this line. Should we do KJ? KJ. And remember, you can flip the order. You could have used L and K. Again, just 2 points on that line. Lastly, on E, it says the intersections of lines P and R. Let's see here. P is right here. R is right here. Where do they touch? Well, they touch at point N. Woohoo! Good work, team. Now we are on our last little example here. This one involves some planes, so it might be a little more challenging, but we'll be okay. It says use the diagram to name the following. Name 3 coplanar points. So we have to find 3 points that are on the same plane. We have many options here, so I think the easiest thing is just pick a plane and go with it. So should we pick like this right side of this pyramid here? Because look, this is a flat surface. It's a plane. So we could say points Z, W, X are all on the same plane. So points Z, W, X. Name a plane containing point X. Well, where is X sitting? It's sitting on this bottom plane, right? So just pick a way to name that plane. Remember, you can use this scripted cursive letter in the corner, or we can pick 3 other points on that plane. So let's just write down our different ways. We have plane R, or you could say plane V, W, Y. Good work. The intersection of plane R and plane Z, V, Y. So plane R is this whole bottom guy. If it helps you, right? This whole bottom guy is plane R. So we want the intersection of the bottom and plane ZVY. ZVY is this guy here. So where do those guys share points? Well, they share points here on the bottom, right? That's where they're touching. So we could say line VY or YV. Now this is always kind of like a tricky question. It says, name how many planes appear in the figure. Well, let's look. If we look at the pyramid, all the sides of a pyramid are a plane. So we have this left side, this front side would be 2, this right side would be 3, and this back side would be 4, right? And then think this bottom, this whole bottom here is the same plane, so there's actually 5. We have 5 different figures, or the 5 different planes in that figure. And now our last question here says, how many planes contain point W? Well, here's W. So it obviously falls on the bottom plane, so that's 1. It's on this front wall of the pyramid, so that's 2. And then it's also on this right one. So there's 3. So 3 different planes have point W. Okay, I know that was kind of rough. They will get better. I will get better. Thank you for watching. I hope you have a super great rest of your day, and I will see you next time in class. Have a good one.